Hey class, so today we're going to be going over Chapter 3, Objective 1. And this video is just for anybody that missed the lectures or you just want to watch this content to kind of get a refresher on this chapter. So the first objective that we're going to talk about is reading graphs um, and the rectangular coordinate system. So these are the objectives that we want to try to reach and get a better understanding of. You can read them for yourselves. I'll just kind of basically summarize them. So we want to reiterate how to read different graphs, like bar graphs and line graphs. We want to talk about what coordinates are, and we want to define the rectangular coordinate system. This is so that we can use data points to create ordered pairs that we're able to chart onto this coordinate system. And we'll be able to do different things with correlation, as well as finding whether or not ordered pairs are solutions to certain equations or expressions. Okay, so let's just jump into it. So the first thing we're going to talk about is different graphs. So the bar graph shows a series of bars arranged vertically or horizontally. The name kind of gives it away. They have these little bars in them. So these bars, when you're looking at them and it might ask you to estimate numbers, this is something that if you're not 100% used to right now, with more practice, you'll get kind of better at eyeballing good measurements or good estimates. So for example, if we just look at the year 2000 here, and let's say we wanted to estimate the number of paid attendance at the Super Bowl in this year 2000. Well, we can use this y-axis right here, this vertical axis, in order to kind of match up the top of this bar to a measurement. So this looks a little bit more than 60,000. So we could say something like 70,000, but we could also be justified in saying something like 72 or 71,000 as an estimate for the year 2000. And this is how we read these types of graphs and also how we kind of get information from it. Another type of graph that we can do this for is a line graph. So a line graph, what it does really well is it shows the change in years. So instead of having these bulky bars, a line graph just shows you points and then connects those points with a straight line. So anytime a point is going down, that tells you that it's decreased a little bit. So the number of Super Bowl attendance decreased from the year 2000 to 2001, very slightly. When the line is going up, and I mean going up from left to right, going up in that direction, that means that there's been an increase in whatever number we're measuring. So for example, from 2006 to 2007, there was an increase in the Super Bowl attendance. And just in the way that we did our estimation with the bar graph, we can do the same thing here. So we can kind of just eyeball a straight line from whatever point we're trying to measure to the y-axis, this vertical axis right here, and then use that line to kind of guesstimate a total. So that is the line graph and the bar graph. Let's go ahead and jump into an example. Okay, so I'll walk you through the first parts of this, and then I want you to try to solve the last two parts of this on your own. So here we have a bar graph talking about the top 5 internet users. And the first question it asks is find the country that has the most internet users and approximate the number of users. Excuse me. Oh. So in this case, our bars are horizontal, not vertical. So that means that the most internet users, oops, don't know why that happened. Okay, so it means that the most internet users will be farther to the right on this graph, on this bar. So if we look for the bar that reaches the farthest to the right, we see that the United States has the most. And again, to approximate it, you can either draw a straight line or just kind of eyeball a straight line kind of downwards compared to this 200. And I'd say this is probably somewhere between 198 to 199 million users. So one thing I can highlight in this part is that often when you have really big numbers that you're graphing, in this case we're trying to graph hundreds of millions of people, instead of writing the entire number 198 million, they'll just write 1 to 3 digits and then put a parentheses here on a label to tell you, okay, these numbers are in millions or in thousands or in trillions or whatever. So that's something to keep in mind as well. So the second part of this question asks how many more users are in the United States than China. So this is kind of a two-part estimate. So first you want to find out how many users are in China. And this estimate's pretty easy. It looks like the bar for China right here is straight on this line. So I'd say that estimate is right around 120 million. So China has roughly 120 million users. So to figure out how many more America has, or the US has, we simply subtract this 120 from our estimate of the amount of users that the US has. So we would write 198 or 199, whichever estimate you think is better. And this would be roughly about 79 million. Oop, I did my addition wrong. 78 million is what I meant to say. So, oh my gosh, what is happening? So, this is how you do estimates and solve problems dealing with bar graphs. The next two parts are find the country shown with the fewest internet users and approximate the number of users. And then the last question is how many more users are in India than in Germany. So go ahead, I'll scroll up the video in just a second and pause it, and I want you to try to figure this out on your own. Okay. Okay, these are the estimates I got. So in Germany's case, when you look at the bar graph, one thing I want to point out is that your estimates don't have to be exact, but they should be within a realm of reasonableness. It should be a reasonable estimate, is what I'm trying to say. So obviously Germany is between 40 and 60. So your estimate should at least be between 40 and 60. Now, I would go even further to say that your estimate should be less than 50. Okay, so anytime you have something like this, to where it's less than really half the tick mark, if you will, so these two tick marks, I would say that you should really be careful of this and try to look carefully at where the half mark is that less than the half mark, more than it, and so on. Because this realm, 40 and 50, this is really where I think a good estimate is. Somewhere between 41 and 45 is 41 and 50 is a good estimate to me. I think that's about a quarter of the way, so I estimated it 45. If you said something like 46, 47, 42, I think that's okay. But going forward, India, I did the same kind of thing. This looked like it was about halfway between, might be a little bit more, but I just said it was right in the middle. So I said it was 50 million. And then I just took the difference of these and got 5 million users. Okay, so let's move on. Let's do some parts of this line graph. So here, this is going to be really hard to show because it's kind of on 2 pages. But let's just look at the graph for a second. On the x-axis, on this horizontal axis, we have time in minutes, and we are told that the 0 minute is when the cigarette is lit. So the 0 corresponds to the cigarette being lit, okay? And the negative time, let me highlight this, is before the cigarette is lit. The positive time is after the cigarette is lit. So just making that clearer. The horizontal is the pulse rate. So just right off the bat, things you can notice about this is at 0, when the cigarette is lit, to 5 minutes, this range shows a huge increase. So there's going to be a really big increase here. And then it kind of teeters off. I'd say that's kind of what we can observe from the get-go here. And let's look at what the questions are actually asking. So the first question is saying, what is the pulse rate 15 minutes after a cigarette is lit? So we go to 15 minutes, we go all the way up, and we look at this dot right here. So this dot looks like it's right on this white line. And this white line has to correspond, or happens to correspond, to 80. So this is heartbeats per minute. So that means that the pulse rate 15 minutes after the cigarette is lit is 80 beats per minute. Okay. So the next question is, when is the pulse rate the lowest? So in this example, the vertical axis goes from 0 to 100. So the one farthest down is going to be our lowest heartbeat. And as we can see by just doing a quick scan, it's going to be this point right here. This point happens to correspond to 5 minutes before the cigarette is lit. So the pulse rate is the lowest 5 minutes before the cigarette is lit. Okay, the next one is the greatest change, and this is actually something I pointed out. So remember, on a line graph, you can tell how big or how small a change is by just how kind of steep it is. So this is going to give you a bigger change than this. And the steepest line that goes up from left to right is, like I said, between 0 and 5 minutes. So the answer to C is between 0 and 5 minutes. So part D and E, these, I'll leave this for you to do. Go ahead and pause the video. D is when the pulse rate is the highest, and E is what is the pulse rate when a cigarette is being lit. And these are the solutions you should get. So the pulse rate is the highest at 5 minutes, and the pulse rate when a cigarette is being lit is 60 beats per minute. So let's go ahead and move on to the next big topic we're going to talk about, the rectangular coordinate system. So this is a lot of information at once, but I'm going to try to break it down as neatly as I can. So the first thing, these axes right here are just number lines. So these axes are just 2 of the number lines that you are used to. There's a 0 in the middle of them on the right. There's positive numbers on the left. there's negative numbers. So all we've done is we've taken two number lines and we've kind of put them on top of each other. So now, instead of just having one number line, we have two number lines. And with this one, since it's flipped on its side, the positive numbers are on the top and the negative numbers are on the bottom. The 0 is still in the middle, so this point where they intersect is called the origin, and its coordinate is 0, 0. This thing that I just called a coordinate is also called an ordered pair. So an ordered pair is just a sequence of two numbers, and those two numbers correspond to a singular point on this rectangular coordinate system. Another word for this rectangular coordinate system that I've just created is a plane. So it's just a plane. So if we have the point 1, 2, this corresponds to 1 unit up and 2 units across. So, wait, I said that backwards. I am so sorry. How'd I caught that? So, sorry, this corresponds to 1 unit across and 2 units up. So the sequence is x, comma, y. The x-axis is the horizontal axis, and the y-axis is the vertical axis. So this is kind of what I have all here, but I just kind of wanted to break it up and take it piece by piece for you. So when you put these two number lines kind of crossing like this, you kind of cut this plane or this coordinate system into different sections. And these sections, these little boxes that we make, are called quadrants. So you count the quadrants going counterclockwise. You start with this one, you go 1, 2, 3, and 4. So you go counterclockwise this way. Okay, and those are the basics of a coordinate system. So you have two number lines, one horizontal, one vertical. Each point in the plane that these number lines make just tells you what movement you've made in each number line. And the first number in that ordered pair is your x, or your horizontal, and the second number in your ordered pair is your y, or the vertical direction. Okay. So I have actual definitions here. If you want to take a minute, pause it, write these down, go for it. These might just be more succinct ways of saying what I've said above. Okay. All right. So let's move on to an example with this. So let's say we wanted to graph each ordered pair and state which quadrant each point lies in. So here, let's just jump right into it. So the first point we have is 5, 3. So remember, we're going to move the x first, then the y. So we go 5 on the x. 1, 2, 3, 4, 5. Then we go 3 on the y. So 1, 2, 3. So this point right here will be our A point. All right, so let's go on to B. So B is negative 5, 3. So now, instead of moving to the right 5 times, we move to the left 5 times. So 1, 2, 3, 4, 5. And we still go up 3. So 1, 2, 3. And this point right here is our B. So I'll do 2 more and then I'll let you do the rest. So C is going to be -2, so that's -2 or 2 to the left on the x-axis, and then -4, so that's 4 going down on the y-axis. So 1, 2, 3, 4. This point right here. This is our C. And then the last one I'll walk you through is D. So D is 1 to the right and 2 down. So 1 and then 1, 2. D is right here. Alright, so I want you to go ahead, pause the video, try to map out E through H, and then I'll show you the solutions. Okay, so here I have E through H charted. And it might be hard to see because of just the ink and the way this format works, but this point right here is our E. It is the origin at 0, 0. F is right here on the y-axis because it has a 0 for the x-coordinate. Similarly, G is on the x-axis because it has a 0 for the y-coordinate. And H is on the y-axis because it has a 0 for the x-coordinate. Okay, so let's move on. Let's keep on going. So this scattered plot is something I'll talk more about in the next lecture. But for now, just know that you can take these ordered pairs that we talked about and plot them and look at this kind of box right here as the first quadrant. You can look at this as quadrant 1 because you're usually, I say usually, but you know there's always exceptions, you're usually plotting 2 positives points. So everything that you're plotting is just positive in these scatter plots. However, there may be cases where you're not only plotting positive points. So I'll talk about this later video. For now, let's just try to do this. So this example, we want to write these ordered pairs using this data set. So we want to write the ordered pairs as years and sales in billions. So we're making our x-coordinate now some year and our y-coordinate as some sales in billions. So for example, one of these ordered pairs is going to be 2,181. Another one is going to be 2001 and 204. We're also going to have one that's 2006, 345. So go ahead, fill the rest of this out, pause the video, and do that, and I'll show you what the final solution should be. Okay, so this is the set of ordered pairs that you should see, or you should get from the graph. And now we want to plot all of these. So I might want to zoom out for this. Let me zoom out a bit. Okay. So the first thing I like to do when I'm doing these scatter plots is look at how many kind of years or how many movements I have to make. I'm trying to think of a better word for that, but just like ask yourself, if you're plugging in years, how many years am I having to subdivide into, or how many minutes, or how many hours, or whatever your horizontal axis is. And in this case, we have 7 years in total that we have to plot. So this is 7 years of data. We have 16 boxes in this graph going from left to right. So if I subdivide each year to 2 boxes, that means we're only going to cover 14 boxes, and we'll have 2 left over at the end. So that's what I do. I go down here, I put tick mark here, and I put our first year of 2000. I skip 1, and this is going to be 2001. and 1. So I just keep doing this for each year. It's going to take me a second. Just hang in there. And 2006. Okay, so now that we have our years plotted, it's always good to add a little label. So put something like years below it. Then we're going to focus on this horizontal axis, or sorry, the vertical axis. So in the dollars category, we go from a minimum of 181 and we go to a maximum of 345. So this distance that we have to travel, I like to round down to whole numbers, things that I can divide easy, or round up to whole numbers. Basically goes from 180 to roughly 360. So I round it up, in this case, from 180 to 360, because if I were to instead have kept it at 345 or 350, the distance between 180 and 350 or 345 isn't very pretty. So let me show you what I mean. So if we do the distance between 360 and 180, what do we get? Well, we get actually 180, right? So on the vertical plane, we actually only have, I think, is it 16 again? Let me just double count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we have 12. So we have 12 boxes that we can fill. If we subdivide this into 20, 180 divided by 20, that means we only fill up 9 boxes. So instead of skipping a box, what I'll do this time is I'll just use all of these boxes after skipping 2 of the first, because that means we'll use up 11 of the 12. So let's just do that. So let's subdivide these into 20s, and we start with 180. So 180, 200, 220, 240, 'just doing some tick marks and numbers. Almost there. 360. Okay, so this is what I get. And we could have further kind of spaced this out by doing steps of 40 and skipping 1. But I just kind of wanted to show this because it'll also make kind of plotting these points right here a little bit easier when you do every single box. Okay, so let's plot this, and then let's talk about the trend that this paired order shows. So for our first year in 2000, we had $181. So going to 2000, we go up to 181, which is right about here. And we can just continue this. So 2001 goes with 204. So 2001 all the way up to 204, somewhere like right here. 2002 was matched with 230. So that's somewhere right here. 2003 is 256. And so on. 285. 312, and 345. Okay, if we were to draw a line connecting all of these points, we would get a bunch of lines that are slanted up. And remember that slanting up lines say that values are increasing. So if our whole graph is increasing, what do you think the trend is? Or what do you think the trend says about the data? So this trend and this pattern says that money is increasing every year. So the trend shows us that money is increasing, revenue is increasing in billions of dollars. Or actually, it's net sales. So the net sales are increasing every year. And that is about it for today. So we have another example with some data points that we can do a scatter diagram of and talk about the trend. And I'll also talk about correlation and more about different trends that you can see in scatter plots. But this is it for now. Hope this video was helpful. Good luck on the homework, and I'll talk to you next time.